Hello everyone. Today we are going to discuss the interference phenomena, but before that we need to know what is superposition principle. So we have studied this superposition principle in class 11th also. It says that wherever there are a number of waves, when these waves interact with each other, interact is not the technical word, when these waves superimpose on each other, then the resultant displacement at any place is the vector sum of the individual displacements of the individual waves, right? So this I have already written. It states that at a particular point in a medium, the resultant displacement produced by a number of waves is the vector sum of the displacements produced by each of the waves. Suppose we have n number of waves in a medium, then the resultant displacement at any point will be the vector sum of the displacements of the individual waves, right? There were three cases of superposition in class 11th. There were beats, interference and the standing waves. Now this is the case, interference is a case of superposition when the two waves which superpose on each other are traveling along the same direction. This is the one important thing. Second thing, the two superposing waves must have same frequency and zero or constant phase difference, right? Then only these two interfering waves interfere and show the phenomena of interference of waves. Now, before we understand this technical meaning, so what happens in interference of waves? Actually, in interference of waves, if these conditions, the special conditions which I just told you, same frequency, zero or constant phase difference, traveling in same direction, when these waves superpose on each other, then there is a redistribution of energy. What does that mean? Redistribution of energy means at some places there will be more intensity and at some places there will be less intensity. The places where the intensity is more are called as maxima. The places where the intensity is less are called as minima. And wherever maxima is formed, we say that constructive interference is taking place, and wherever minima is formed, we say that a destructive interference is taking place. So first of all, we'll just state the definition of interference of waves. If two waves of same frequency, zero or constant phase difference, traveling in same direction, superimpose on each other, there is redistribution of energy. This redistribution of energy is called interference. At some places, the intensity is maximum. These are called maxima or bright. And at some places, the intensity is minimum. And these points are called minima. The places of maximum intensity are called maxima. The places of minimum intensity are called minima. This minima is also called as dark, and maxima is also called as bright. Right, and wherever maxima is there, we say that constructive interference is taking place, and wherever minima is there, we say that destructive interference is taking place. So based on this, types of interference are two. One is constructive, constructive takes place when crest of one wave falls on crest of other, or trough of one wave falls on trough of other. We can understand it using this. If this is the first wave, so if this crest and trough and this crest and trough, these are falling on each other, then due to the constructive interference, what will happen? The case will be this Y2 and this Y1, these will be added. So this will be right. In case it would have the reverse case, if crest of one on trough of other, then the destructive interference will take place. So second is destructive interference. When crest of one wave falls on trough of other and vice versa. Then the destructive interference takes place. So we can understand it this way. If we have this one wave, this is this, and we have so this is suppose minus Y2, this is Y2, Y1, this is Y1. So if these superpose, what will happen? So this one is bigger here. So you can see this one is small. So only so this is Y1 minus Y2. This is the displacement. So when crest of one is falling on the trough, then destructive interference is there. Now, when these conditions are required for the interference, these conditions are satisfied if the source of the wave which we are taking is coherent. So what are coherent sources? So coherent sources, these are the sources of wave or sources of light in this case, which produces waves of same frequency, zero or constant phase difference, right, and nearly same amplitude, which are produced from a single source. So this word single source is important over here. Why? You may say that if we take two independent sodium lamps, which are exactly same, right, then you will say that it will produce waves, these two will produce waves of same frequency, nearly same amplitude, zero or constant phase difference. No, it will not be the case. These two independent sources will not be coherent sources. Why? Because these are two sources which are independent of each other. So the molecules and atoms which are vibrating in one lamp may be out of phase with the molecules or the atoms which are vibrating in the second lamp. So that's why, very important point, two independent cannot be coherent sources as the atoms and molecules in different sources vibrate in different phase. So this does not satisfy the condition for interference, right? So this was all about this. Now we have to discuss one more thing in the video, conditions for sustained interference. I'll discuss here only conditions of sustained interference. Sustained interference means which stays for longer duration. Which stays for longer duration. So the first condition is must have same frequency, same frequency of waves, zero or constant phase difference, and coherent sources used. This is the necessary condition. Next is same amplitude of the constituent waves for a better contrast between the bright and the dark. Same amplitude So these are the conditions for sustained interference. So these were the basic concepts related to interference of light. That's all for now. Have a nice day.